All right, part two, we're picking up right where the last nugget left off on rebuilding the ICND1 structure. I'm going to dive into the lab. Last nugget, we went through the scenario, what it's all about, got our 3281 Bitcoin reward, and went through the core configuration, base configuration of all the devices. Now we're moving on into the IP addressing. So it says configure IP addressing appropriately on all routers and switches based on the diagram shown. Okay. So coming back here, we've got our network diagram. Just like you will on the exam, you'll be able to resize windows, see the diagram and your config at the same time. So I'm going to go into GNS3. I'm going to do 2 routers and 2 switches with you, and then I'll leave the rest to you. Let's start off with router 1. Nice logical place to begin. Take a look. Our base configuration is taking effect from the last nugget. We've got our logon banner, and we've got our... Man, was that the line? I think that was the one I demonstrated. I think spontaneously combusting hands is the rest of them. So I'm going to do the password nugget love, because that's what we put on there. Now notice, interesting, that I went straight to privilege mode. This is our GNS3 love coming back to us on router 1, because GNS3 puts in the base configuration this command let me begin with line console. It is actually privilege level 15. Now, this is not part of the CCNA series. Probably not a great practice to do, except in lab environments. But privilege level 15 is the highest privilege level. That's enable mode access, privileged exec. So if you put that under, you can see right here, they have it under the aux port, under the console port. That means as soon as you log into quote unquote user mode, you're granted privilege level 15, which takes you straight to privilege mode, so you don't have to type in the enable secret password and pretty much undermine all your security, but works great for a lab environment. So let's do a show IP interface brief. Router 1, I've got serial 0/0 fast Ethernet 0/0, and nothing's going on yet. So let's go in to serial 0/0, put on the IP address 188.23.163.173. That's our IP address right there. Actually, hang on, let me make sure that window stays on top. 173. And then I look at the subnet mask, it's a /29, which it's not quick and easy for you to do that in your head unless you've seen it a lot. What I do just mentally is I think, okay, /29, that's 29 ones in the subnet mask. So my mind immediately goes to a class C, the closest boundary, right? I go, okay, well, a /24, I know that. That's the first 3 octets. First 3 octets are all ones. So think of that as like 24 ones right there. And then I go, okay, so 29 minus 24 is 5. So I go, okay, 5, 1, 2, 3, 4, 5 ones beyond the /24, 0, 0, 0. So then I can just look at this and go, okay, well, and this is, if you haven't seen this enough time, you'll start recognizing that pattern and going, oh, that's a .248. But before then, you might just add 128 plus 64 plus 32 plus 16 plus 8. Add them all together, and you end up with 255.255.248 as the subnet mask. So now we've got our serial port assigned, and we got to bring that guy up. No shutdown. Waiting for a console message. There we go. It's changed to up. We always like seeing the 2 ups. This is physically changed to up. Line protocol, that's the data link, has now changed to up. So we should be able to do a show IP interface brief and see that our serial interface is online. Good. I want to ping the other side, but I'm not going to do that yet. So let's go into interface fast Ethernet 0/0. IP address, what we got going on here. So 10.23.0.0/24 is the subnet. We've got .1 as the IP address of router 1. .2 is router 2. So let's do it. 10.23.0.1. No shutdown. Good. So we've got router 1 assigned. And now, so actually before we go on to router 2, I'm going to save my config. And I'm going to ping the other side. Let's do ping 188.23.163.174 is the ISP, right? 174. Beautiful. So we now have quote unquote internet connectivity. Now if I actually ping something beyond like 4222, it's not going to work because we haven't defined any default routes or anything like that. That's going to come later. Okay, let's jump down to router 2. Cha-ching. Bring him up in the picture. Good. There's my spontaneously combusting hands. So password is Nugget Love. If I type it right, there we go. I'm on router 2 automagically in privilege mode. Now I can look at my IP address. Let's kind of shrink this down too. There we go. So router 2 show IP interface brief, my favorite command. A lot of serial interfaces. So it's saying that serial 0/0 is connected over here to the other side, serial 0/0. So let's go into interface serial 0/0, IP address 10.15.1. Okay, it looks like .12/30, so .12, so this guy's .13. IP address noted right there. 13. 255.255.255.252 is a /30. Enter no shutdown, and then we'll go under fast Ethernet 0/0, IP address 10.23.0.2. That's our IP address happening right there. .2, 255.255.255.0, no shutdown as well. So good, we've got our two routers configured with an IP address. Now let's do our two switches after we save that config. And just to make sure we're all working, ooh, look at that. Little duplex mismatch action. Gotta love that. We'll fix that later. So let's do a ping 10.23.0.1. Just make sure that we're talking over to router 1. Yeah. There we go. So we are pinging through to the other side. Good. Let's hop over to switch 1. Bring up GNS3. Minimize this guy. Let's bring up switch 1. Now switch 1 is really a router with an ether switch module. But that's okay. It works. Okay, there we go. Double click. I did volunteer work teaching elderly people how to use computers. That's interesting. That's a fun thing. And just doing like double click. I just remember. Okay, it was like this was a long time ago when Little Caesars always did their pizza because they always have two pizzas in this big package. And I was like, okay, double click is like pizza. So I had all these elderly peoples around computers going pizza. So anyway, every time I think double click, I think pizza. So Nugget Love. Logging into switch 1, which we configured the base config in the last nugget. Getting those duplex mismatch messages, which I think later in the lab we're going to fix that. I do not have that privilege level 15 here, so you can see that I go to user and privilege the way it should be. Now notice switch 1, we've got .11. So we look at the site IP address 10.23.0.0, and we say, okay, this is going to get the .11. Now the weird thing is this guy really is a swouter. It's a switch and a router combined into one because we've got this ether switch module. However, we're not using it as a router. We're using it as a switch, and every switch actually has this VLAN 1 interface, which by default, the default VLAN 1. Oh my goodness! Seriously? I've had that there the whole time. I'm broken. So wait a sec. Did I do this wrong? Okay, one of these are wrong. So I told you something was going to pop up. Okay, so I've got 23 right here and 24 down here. Quick fix. Have you guys been looking at this the whole time? You're like, Jeremy, you're broken. Hang on. Okay, I think, yeah, this is what I want to do. I want to, which I'm kind of like, oh, bummer, because I have to fix it. But I want to make this 24. So that way corporate office is everything 1024, and the branch offices can all be this 10.23 world that we're working with, which means I've got to go over to router 1 and router 2. Just bring up router 1. Oh, because router 1's already there. Bring up router 1 real quick and do a show IP interface brief. And this will be a quick fix. IP address 10.24.0.1. And I'll fix the diagram before long. And then shoot over to router 2. See, we're getting bonus IP address work. Config T, interface fast 0, IP address 10.24.0.2, right? 255.255.250. I don't have the diagram sitting in front of me. But I think that's what we should be. 10.2, yep, 0.2. There we go. Control Z WR. So, all right. So good thing we didn't get too far. Okay. So then I'm looking now here at the switch. I'm going to say, okay, this VLAN 1 interface, which is actually all of these right now are assigned to VLAN 1. So every one of these interfaces. No, actually, let's do a show VLAN. Actually, show on these ether switch modules. On a real switch, it's show VLAN. On an ether switch module, it's show VLAN-switch. So you can see all of my ports here are in VLAN 1 on that ether switch module. So that allows me to go into interface VLAN 1. Whenever you type in VLAN 1, you're configuring the VLAN. When you type in interface VLAN 1, you're configuring the layer 3 interface in that VLAN. So I'll give it the IP address 10.24.0.11. And I'll type in no shutdown because that's just what we do, even though it's not shut down. Let's just ping the two routers on that network just to make sure that this switch is getting out. Good. We ping that guy and 10.2.0.2. Now, everybody's like, why you drop the first one? That's because of the ARP message. It sends the ARP, but the timeout is so sensitive on Cisco routers, it's like, it didn't come back in time. So we usually drop the first one, not always, but usually drop the first ping when we ping a new IP address. Okay, so feeling good about that. Okay, let's do one more switch, and then I'll do all these in the background. Hopping down to switch 2. Duplex mismatches everywhere. Get these guys out of the picture. Switch 2, bing. Nugget love. Enable. Cisco. Config T. Interface VLAN 1 IP address 10.24.0.12. 255.255.255.0. Okay, good. No shut. Just make sure ping 10.24.0.1. Ping over to the router. Bing looks good. Let's ping over to our switch friend. Even with all these duplex mismatches, looks good. We're communicating over the other side. Okay, good. So with that being said, I'm assuming you're feeling warm and fuzzy about configuring IP addresses. What I'm going to do is go through switch 3 and actually router 3. There's only 2 left. Configure those guys behind the scenes, then we'll come right back. All right, I got router 3 and switch 3 configured, just so you can see router 3 is now able to ping. This is the serial interface to the other side. Switch 3, I just verified that it's able to ping the router IP address. So the 2 missing devices are there, and I found another glitch. I forgot to put the IP address right here. So all this stuff will be fixed by the time we get to where you actually look at the lab. It's just I discover it as I go. Okay, so router 3 is now good. Now notice router 3 can ping, of course, to the other side, router 2, but it can't actually ping beyond that. If I try and ping 10.24.0.1, we'll say, which is router 1, it can't. And the reason why is because as of right now we have no routing. If I do a show IP route, it knows about its connected interfaces, but nothing else. So these are the only networks, router 3, and if, in fact, every other router out there will actually know how to reach. Okay. So, looking at my next thing in the lab, you can see that it says hardcode all the speed and duplex between the routers and switches at the corporate office. That is a very good practice, especially if you're in the fast Ethernet world, because it just auto detection has all kinds of issues. As you can see, what I'm showing you here, when I brought up all these routers, and they're just, hang on, let's see, where's router 3? Is that this guy? Or one of them? Oh, switch 3. Right? Yeah, to where you start seeing all these duplex mismatches all over the place. This isn't something that I went in there and planned and sabotaged and things like that. That's just how things roll in the Cisco world when you leave auto detection on. So I'm going to go to the corporate office. So switch 1 right here. Let's bring up this guy. I think what I do is I keep double clicking the name and it doesn't take. I got to click the icon. Okay, so I'm going to do a quick way to find out everything that's there. I'm going to do a show CDP neighbors. Sure, I could look at the diagram, but I just like seeing everything in this quick list. So I'm going to say, okay, switch 1, I'm going into, and by the way, this is not something to do during production time, because it will cause the interface to go down and come back up. It'll kill whatever traffic is there for a few seconds. And you might be saying, well, a few seconds, who cares? Well, with voice over IP, you do care. So fast Ethernet, let's go 1/0. We've got that going to router 1. So I'm going to do speed 100, duplex full. Now you're going to see my interface is flapping when I do that if I actually have logging on there. Now, also, there we go. So you can see it went down, it's come back up. One of the things worth mentioning, if you hard code one side, if I say this one is 100 full and we leave this side as auto, you are guaranteed a duplex mismatch every single time. Because what happens is this guy stops participating in the auto detect mechanism. So this guy's like, hey, you want to negotiate? He's like, that's exactly right. Totally silent. Does not respond back. So the way the 10100 standard is written is if a network card cannot detect the other side, if the other guy's not talking and participating in auto, it will default to 100 megabits per second. Well, again, if I'm 100 megabit per second network card, half duplex. That's the way the CSMA CD standard is written for Ethernet, which said default to half, because back in the day when 100 megabit per second came out, half duplex was the norm. We didn't have this whole full duplexing. That was like cutting edge technology back then. So if you are going to hard code one side, always remember you got to hard code the other side. It's funny too that CDP is like, hey, I've discovered a duplex mismatch. You would think that Cisco would have a command like fix it, You know, or like duplex fix or something. Like, if it detects it, can't it just fix it? But obviously not. So let's fix the other two. I'm going to go into interface fast Ethernet 1/1, which is going down here to switch 2. Do that speed 100, duplex full. And then into interface fast Ethernet 1/2, speed 100, duplex full. So what I'm going to do is I'm going to go to every single device. So that was switch 1. I'm going to do router 1, and then I'll just do the rest of them behind the scenes because you'll get the idea. So there's router 1, who is currently, let's do a quick show CDP neighbors, currently connected to the ISP. Now there is no speed and duplex mismatch issues on serial 0/0 because it doesn't. It just defaults to full duplex. So I'm going to do let's do just verify show interface fast Ethernet 0/0 that I can see. Now I'm seeing a duplex mismatch, and sure enough, when I do the show interface, notice it says okay, well, actually, we've got a 10 megabit per second. Woohoo! It's running at 10 meg, half duplex on this interface on router 1. Now that I would probably say is a GNS3 fun-loving default, because if it's 100 meg per second in the real world, it will be at 100 meg per second. But I'm going to go into interface fast Ethernet 0/0, speed 100, duplex full. Issue resolved. So that's all I need to do. Show CDP neighbors on this router, and now we are fully communicating to the other side. So I can go in and verify right there, full duplex, 100 megabits per second. Okay, I'm going to run through the rest of these, go into switch 2, switch 3, the router 2, and hard code those using CDP and manually typing those in behind the scenes. Okay, and that is now done. Only other thing that I did was, since these computers are really Cisco routers, is I hard-coded the speed and duplex here and here as well, because they were getting mismatches. So you'll see that in the post configurations. Also, in the GNS3, I wanted to mention this. GNS3, you see a switch right here, but this is not a switch like the others. This is the GNS3 emulated switch, and that's why in the diagram I represented that switch as just a line. So we don't have to worry about speed and duplex mismatches here, because it's the GNS3 imaginary switch world that is connecting those together. Okay, so what I'm going to do, I'm going to fix these diagram errors, and then we'll continue on in the next nugget with the lab. I hope this has been informative for you, and I'd like to thank you for viewing.